View models in SwiftUI are surprisingly controversial. That's because SwiftUI was designed with state management baked right into the view. In my experience, as the app grows and networking calls come into play, view models can help manage responses and keep the UI focused. We already have a view model in our current app. However, this view model is working with the home, title detail, and upcoming screens. To keep things better organized, we can make a new one to just focus on the search screen. Hit Command N, Swift file, next, search, view, model. Great. Like our first view model, this one also needs to observe changes to its properties and communicate them. To do this, we can type @observable class search view model with braces. We're using a class here because it's a reference type, meaning changes to its properties reflect everywhere it's used. We've used enums to keep track of the different fetching states so far in the course. For this view model, we'll keep it simple and start with an optional property in case an error occurs. Private set var error message :string ? Private set allows only this file to set the value of error string while still allowing others to read it. We'll also need an array of titles to store the results. Private set var search titles :title equals empty brackets. Making the array empty ensures it's ready to use and won't need to be unwrapped later if something fails. The last property we need is an instance of our data fetcher to make the API calls. Private let data fetcher equals data fetcher. It's completely private here as no other file will need access to it. Let is also used because it won't change. Our properties are ready. We can now make our function. Func get search titles by media :string for title :string async with braces. Media will change depending if you are in a TV search or movie search. Title is a search term the user will enter in the search bar. Async is used as this function will be making a network call. Inside our function, write a do catch block. Let's go reverse and fill out the catch block first. Print error message equals error dot localized description. This prints the error to our log and assigns a user-friendly message to our error message. We'll display the error message in our UI later. Inside the do block, error message equals nil. If title is empty, search titles equals try awaits data fetcher dot fetch titles for media by trending. We first clear out any error messages. Title is going to be what the user types into the search bar. If the search bar is empty, we'll return a trending list of movies or TV shows, depending on what the user is searching. After the if statement, type else with braces. Before we can fill out this else statement, we do need to make an adjustment. Open data fetcher. Currently, our fetch titles function doesn't have a way to add a search term. We can fix this by adding another parameter. After string, add a comma with title :string ? Equals nil. This creates an optional parameter called title and assigns nil if it's not used. Title will be how we pass our search term. With our new parameter, we just need to adjust the build URL call. Add a comma after type, search phrase :title. Our build URL function was made to complete the search URL only if search phrase is not nil. With this adjustment, go back to search ViewModel. Inside the else block, search titles equals try awaits data fetcher that fetch titles 4 by width. 4 will be the media passed in the arguments. We can pass search in for by. Width will be title. In hindsight, it would probably be better to group our parameters with enums. If we were working with a team, they most likely wouldn't know to pass in the string search or trending for the different API calls. Just some feedback for our own code. This completes our search view model. All that's left is to wire it up to the UI. We'll tackle this in the next video. Thank you for watching.